Hello again, Kevin Culp from SuperLikeWell, continuing our podcast on managing and monitoring Ampere-based servers in our software-defined data center. In the previous video, we focused on PDU management, adding a Schneider Electric type of PDU to our rack, and we went through the various different regions that you can define a particular PDU. And we completed three 2U Ampere servers within our software-defined data center for rack management. So we're going to continue on with pod view registration and adding the fourth Ampere server within our Ampere farm configuration or pod. And we're going to associate that server into the second floor rack that is basically has no managed PDU in it, just a very simple PDU and providing lifecycle management for that 1U Ampere server. So we're going to go through device discovery again, plug in the IP address for the ARS-110M-NR server. So we're going to plug in that IP address of 172.24.199.120. And again, the ending range is going to be 120 because we don't have contiguous IP address space to discover multiple Ampere servers. So we're going to click submit here. And then we're going to wait till it turns and works in the background here. As I mentioned, you don't have to be confined to this particular screen. You can perform other lifecycle management or perform other tasks while that is cooking in the background. And lo and behold, we've discovered it. We're going to click on that. Again, nothing changes. We're going to associate it with the Ampere farm. And in this case, instead of choosing 6F1, we're going to use the second rack. And we're going to start in rack location 1 of the rack. And then we're going to click save. And then that's going to basically submit that to the back end to collect very important attributes of the 1U Ampere server and collect the appropriate metadata, package it up, and provide it a unified dashboard experience for our software-defined data center. So we've finished the day 0 through day 1 activity, and we're moving into more focused on day 1. And that really has to do with what can we do with this server, right? This lifecycle management. How can we look at information about this Ampere server that we want to basically collect and make those data-driven decisions? And we're going to move now into the second phase of our day 1 activity. And this now has opened up and provided us server management functionality for servers that have been registered within PodView or the drawer configuration. And we're going to look through the list of information here and see if we can identify those particular Ampere servers that have been provided within our configuration of PodView. And so we see here 2 that have been identified and discovered, right? And that has to do with the first one of servers that were identified in the Phoenix data center in pod location RSU1 and also on floor building 6 floor 1. And you can see here where we have that appropriate metadata. So we can click on this option here, and then that opens up additional information of this server, right? So here We provide a carousel view of information that is associated with this ARS 520M server SKU, which is an Ampere server, which is the first generation R12 of the Ultra Max processor. And by hovering over or keeping my mouse in the carousel view, the scrolling of the metadata that is discovered or presented or exposed within the carousel view stops, right? And then by looking here, you can see here all of the various functionality of lifecycle management you can perform associated with this server. So because it's an Ampere server, we do nothing different in lifecycle management. We provide the DevOps administrator the ability to perform lifecycle management for any semiconductor server within your software-defined data center, whether it be an AMD, whether it be a Intel Ampere server or an NVIDIA GPU server, right? All of the various lifecycle management we can perform for your hardened data center. And by clicking on each one of these icons, you can perform power management, shutting down the server gracefully, and all of this information of these data for lifecycle management of these tasks are basically passed back to the PMC through a Redfish endpoint schema call. And so all of this information is available to you, erasing simplified storage, updating the firmware BIOS and BMC, clicking on the BMC itself. By clicking here, you can perform and get connected into the BMC by clicking here, and then by then being prompted for a username and password. And so let's do that. And by connecting into the BMC, and you can see here that now it's opened it up, and we can see various information about the BMC, showing you a GUI of this server and accessing our BMC, right? So the purpose really of providing a lifecycle management tool like SuperCloud Composer is to be able to support a one-to-many relationship, providing enterprise management or lifecycle management for a number of Ampere servers, right? If you were utilizing our standard DCMS lifecycle management or our license for BMC that turns on Redfish functionality, you would be constrained only to be able to support that server, right? Now, there may be use cases out there from an ODM play that you want to build your own lifecycle management platform of utilizing Ampere servers, right? And we have different types of business models where we support those software companies that want to provide their own lifecycle management suite associated with lifecycle management in their hypercloud or in their own type of telco use case or whatever use case is on the vertical to support it. But Supermicro is focused on a vision of providing open standards based for all semiconductors in the industry. So today, SuperCloud Composer is the only server manufacturing platform or enterprise management platform today that supports complete day zero through day two lifecycle management for Ampere-based servers. Only server manufacturer in the world today globally that supports lifecycle management. And we're continuing to evolve as a company, right? As we build in important feature sets within our open BMC for R12 and R13 use cases for Ampere servers, we're going to be able to enhance and enlarge the ability of lifecycle management we can provide, such as collecting important sensor data for a particular BMs for a Ampere server, right? If you're deciding to put GPUs in there to perform some inferencing models, accelerators such as different accelerator manufacturers are providing crucial sensor data to be able to get an understanding of how well your LLM models are running specifically in an Ampere use case. So we showed you here how to log into the BMC of the Open BMC itself, and you can see it various information. All of this information is provided in the GUI and can also be extracted through what we call Redfish endpoints through OpenBMC, and providing a unified dashboard experience for those DevOps administrators for the enterprise, right? All right. So went a little sideways there to show you how you could get into the OpenBMC of the Ampere server. So by reviewing the physical asset information here, you can see here things like product family. You can see the type of product SKU. You can see motherboard type, serial number, form factor, the manufacturer Supermicro, and so on and so forth, right? All of the information that's going to be vital that you could perhaps data mine, right? So you can click here and be able to dump important attributes of this particular server or all the servers that are Ampere servers within your environment. Or you want to dump AMD server and also NVIDIA servers, right? Such as our GPU servers, and you want to dump Grace Hopper type of systems, and you want to dump Intel Gaudi, Habana, or any enterprise grade server such as Blades, things like DC Cloud, things like our gold SKU product offering, right? But today we're focused strictly on lifecycle management for Ampere servers, which is very important for telco operatives, for hyperscalers, and for other use cases for AI infrastructure that you might want to deploy within your data center. So all of these buttons here are available to you that can perform simple lifecycle management on your server. Things like deploying an operating system, which we'll talk about in a later video of how you would deploy an operating system to a Ampere server, right, which is capable of doing so. Or performing some type of lifecycle management for your switches that are that are connected into your Ampere use case, right? As far as providing top of rack switch provisioning of allowing connectivity to compute or the compute side of the house as far as SuperCloud Composer is. So again, we've identified basically this 2U server that has now been registered under PodView, right? We can go back to the PodView rack and see here these servers that have been registered within SuperCloud Composer. You can see here the 2U servers here and the 1U server. So once they actually have been registered within PodView, they are now candidates to be able to be monitored, managed, and perform server lifecycle management for your enterprise. So let's go back to our compute here. And I just want to show you here on the system list, we have a number of servers here that have been defined within our data center. So if you want to perform simple tasks associated with filtering out of looking at specific servers, so maybe I want to see all all of the Ampere servers, or I'm looking for a specific product SKU, I can type it in here and then be able to perform that, right? Maybe I'm looking for the product family of the mega type of family, right? Super of super micro servers, right, or Ampere servers, right, which will be listed here in this list, right? Um, and then we can perform filtering mechanisms for mega DC family. So maybe I want to show the mega DC family of servers that have been a part of that family. I can basically plug it in here within the product family, or any server for that matter you can look at, right? So we can see here now that there are basically the three types of servers that have been registered as 2U, and then here is our 1U server here for Ampere server that now has been registered. So if we want to look at the 1U server, we can click here, and then that's going to open up and show us physical asset information about that 1U server. And then we can go on to the side card here and look at detail about that server, right? What's important to that server, such as the processor. The processor is a one socket server itself, and it is 128 cores installed. And you can see here the model is the Ampere Ultra Max, total cores of 128. We can look at memory here. So memory here showing you information. In this particular memory, we are occupying 2 slots, actually 3 slots of memory, because the other ones are reporting, 4 slots of memory, 1, 2, and 3 and 4, right? So we have the DIM locations of where they're located. We represent the part number itself, the size, the device type being DDR, the serial number of that DIM, and then also the manufacturer. So all the other slots are not occupied, and then we just report them as basically 0 GB because they're not occupied at this point, right? So we show on the right-hand side those particular slots that are occupied as far as memory slots are concerned. We can look at local storage. In this case, we don't have any local storage for this particular system, and so on and so forth, right? We can look at adapter information, the NIC information, again, providing that detail, the MAC address, and we have basically two NICs that are inside this particular server. And then if you had a GPU that was present, we would have GPU information, no HBAs present, and we can look at FRU information here, such as if you wanted to make changes because perhaps you needed to replace the system board, we give the ability for you to change it and essentially reflect the new motherboard that's been replaced. And then also we can affect and change DIM information too as well. We can reflect it here. And then this is just the ability to do a reload operation. So each time we go through the sidecard information, we've taken the lifecycle management and basically allowed those to be available to you in the top right-hand corner so that you don't have to backtrack in your screens, right, to perform the necessary lifecycle management you need to do. So this is actually showing you collecting lifecycle management for particular Ampere servers. We have additional servers within our data center here that show up here. And again, performing lifecycle management for any of the servers that exist here. You can pull back up the 2U server here as well and look at additional information here indicating an Ampere Ultra Max processor. Memory in this particular server is much more populated. As you can see here, we're using Samsung DIMMs, and it's fully populated with a 512 installed in its NUMA region. So all of this information is available at your fingertips itself. And because it's only a single socket, we only provide you with one NUMA region. In servers that are dual socketed, we'll provide two NUMA regions. And you can look here and see here additional information such as the NIC information, local storage if there was any present, and so on and so forth. And again, carousel view information available to you, the type of SKU it is. And if you wanted to go back to a shortcut, back to find out where this is located, you can click here, and then you can basically either navigate back to the pod view, look at monitoring detail analytics that are present here for bandwidth, memory, and so on and so forth. So here you can do the shortcut back to pod view. It will then provide you where this was located. And this one is in a rack slot unit 3, showing you the information about it, right? And if you wanted to look up at the pod view group level, you can click here. Shows you both racks associated with both two racks associated with the rack Ampere farm group, and then you can granulate or go into each rack and look at information for each particular rack. You can notice here that we have rack slot unit 1 occupied in the building 6 F2 Phoenix data center, which is rack number 2, which is our unmanaged rack. And then our managed rack is in building 6 F1 Phoenix data center. So that concludes lifecycle management for the server. Look for next videos where we'll start looking at monitoring detailed information out of band for this particular Ampere server farm, and then performing deployment of an operating system through different mechanisms within SuperCloud Composer, such as fast deploy or deploying based on our artifacts section. That will be in the next subsequent videos. Thanks for joining today. Thanks for sticking with me. I wish you a great day, and we'll see you next time.